I've highlighted I'm focusing this talk on three things that I think you have to also think about as well as or before you think about data sharing. Then that allowed me to give this title about a three-legged stool. Before I get into that talk proper, I've just put a few extra slides in here which are about some of the things that keep coming up in so many discussions, and I just want to deal with them and move on. For too many years, research and healthcare have been separate. They're different domains, different people, operate on different principles, just in every which way, they're different universes. And if we're trying to bring the data together, people are talking about this learning health system where research data feeds into healthcare, healthcare data feeds back into research, and one learns from the other, which is absolutely what we want to do. But I don't see it as just that circle. I actually see a connection between the two, or a sort of overlapping or merging between the two. So it's about the data or the knowledge engineering that we have to do to bring these two worlds, universes together. And that's where I'm coming from with all the things I'm doing, beyond the things I'll present today. That's one thing. Second, this silly debate about, well, should we build a centralized or a federated system? Well, there's pros and cons for each, which I haven't got time to go into. But that isn't. The understanding of this topic needs to go way beyond that. You should be thinking about cloud. Is that centralized? Is that federated? It starts to make you realize that centralized and federated aren't really completely different beasts. The cloud has a big role in this. And then you've got to say, well, what are we actually talking about? Centralized, federated, to share the data, to discover the data, to analyze the data, to curate, link, store the data. It might be that you, for a certain use case, decide we need to have the storage and the curations done in a federated way, but then the discovery and sharing in a centralized way. You probably should be looking at mixed arrangements, and I don't think there's any situations where a fully centralized or a fully federated solution will do all the things you need to have happen. So that's the second general thing that keeps coming up in discussions. The third is, how do you make these, if it's not centralized, how do you make these systems talk to each other? One argument is, oh, you can't build such a complicated federated system because then everyone's got to agree to all the same way of setting things up for it to work. No, these Lego bricks work because they have the same pimples and the same holes. I don't care how long, how short, how wide, what they're made out of, what color they are. Many, many things can vary in your different setups, as long as the few things that you need for them to interoperate, and they don't even have to be standardized, they can be harmonized or transformed. As long as they can communicate and interact, and you concentrate on getting that bit right, a federation really does work. But it's more expensive, I will say that. So that was my sort of general introduction there. So let's get on to the three legs of this data sharing stool. I've highlighted three things. Consent, so what can you do with the data? How do you know the data even exists? How do you find it? Or the samples, or standards, whatever. And how do you link data together in a safe way without risking patient confidentiality and privacy? I'll take them in turn. So, starting with consent. I use the word consent because it fitted on the previous slide, but in fact it's much more than consent you need to consider. There's obviously, at the top there, the individual consent that the subject can choose to give or not, and different flavors of that. But then as you go beyond that, you've got what is the scope of the research, the stuff that's not, the patient can't choose or not about. They're in the research, they have to agree to certain terms, so the study protocol. Then the requirements of the researcher, the institute, they might want to own the IP or be co-authors on publications. There's all sorts of things coming to play on that level, and then the backdrop regulatory environment. So in fact, to know what you can do with an asset, whether it's data, biosample, patient, whatever, requires a lot of digging around in lots of documents, and that generally is not possible because the information is all over the place and complicated. Here's one aspect of that complexity. There's the focus or the reference point. What are we trying to what question are we trying to answer? Are we trying to answer the question, what can be done with a particular data set or a collection of data sets in a database? Are we talking about all data on the patient, so it's the patient level, or is it a policy level thing? We'll just group the data as patient data, and then we'll concentrate on what can the doctor do, what can the nurse do, what can the public do with those data. So there's different ways to think about what level you're thinking about this, but then there's that whole research healthcare divide. In research, you would handle this and think about deploying the data one way, in healthcare a different way. So you can see there's this kind of multidimensional challenge to defining what can and can't be done with data. And then there's the lack of any standardization, really, in how this all happens. So you see at the top there, the people who design the consent or gather the consent or define or interpret the legal policy requirements, the institution requirements, all of this, it's all over the place. It is not standardized, it is not written down precisely, it is open to interpretation, you know, and it's all over the place. It's on written notes, PDFs, Excel sheets, people's minds. You can see the mess. And as a result, no one knows really what can and can't be done. When someone asks, can I have the data, you go, oh, I don't know if you can use it for that. It's a big problem, and it compromises all these possible uses. So the last few years, several years ago, I started arguing in the context of Global Alliance for Genomics and Health, we should really create a structure to capture all of this and make it computable. And that, I lobbied that for 18 months. Eventually, the standards organization said, you know, we should do that. But they turned around and said, you're going to lead it, which is not my plan from the start. But I kind of had to say yes. So I found a co-lead in John Wilbanks, who some of you may know, and we set about doing that. We ended up with something called ADAM. We called ADAM. And I should have written down what ADAM stands for. I think I did somewhere. Yes, it's down the bottom there. Automatable Discovery and Access Matrix. So keep that in mind. A matrix, what does it mean? It's just a structure to put this information into. The approach we took, the philosophy we took, was to try to identify the pure alphabet, the pure concepts of consent and use, and tease them apart and have them in this structure, and make that sufficiently rich that it was give you essentially a semi-comprehensive set of parameters about conditions of use, and in a digital computerized structure. And it's important, I need to stress this, we tried to concentrate on what would be the smallest, sensible, practical concepts in this structure about conditions of use. And then, of course, we did all the computer stuff, defined some formats for this and supporting APIs and so on. And I really want to stress the philosophy here. What I've just told you about is the bit in the middle. We tried to define the letters, the pure concepts, from which you can make any word. And if you need a different word next week, you can make that. You've got the letters. Other approaches out there, they try to pre-package these elements into consents. You know, a whole package of things, and then give that's the unit. That's like the Chinese language. But each word then needs a different structure. And you get a never-ending set of codes. So those are two different philosophies. We took the alphabet type philosophy. Some of those other philosophies and other different approaches for that multi-dimensional challenge that people are trying to tackle it different ways, they're listed here. There's various efforts out there, but I'll now tell you more about ADAM. This just gives you an idea of what those elements, those letters, those core concepts are. Where can it be used? By what organization can it be used? Can it be used for research, yes or no? And if yes, then you can go one level below that. What kinds of research? Methods development, as a reference material, biomedical research, and then again, well, what kind of biomedical research? To try to break it out into these things. And additionally, some rather more complicated areas which we couldn't categorize so neatly but had to be in ADAM, such as, well, do you have to have any formal documentation, paperwork, approval before you can access it? Are there any requirements about publication or acknowledgements, timeline restrictions, and so on? So throughout this whole structure, we designed it and phrased things such that if the answer is yes, positive, then you're good to go. So, can it be used within any location? Yes. Okay, then we don't need to check where they're asking to use it, because it can be used anywhere, and so on. For all of these, if it's a positive answer, you're good to go. Anytime, there are no double negative, there are no timeline restrictions. Yes, that's true, but there are no timeline restrictions, so you're good to go. That's the general design of it. I don't have time to go into more detail, other than to stress only any one of these items need to be filled in for it to be a valid profile. You can adapt this concept. You could add in other concepts that we maybe missed, or ignore the ones you didn't want if you wanted to deploy this kind of approach. Having those things teased out and in a formal structure allows us to define a set of logical rules, so that a profile, we call these ADAM profiles, about consent, are not internally inconsistent. So we've defined 7 rules for that, and we've implemented that in some software so that you don't have to do this in an Excel sheet. This is, on the left, you can see the structure of ADAM. You select the item you want to say something about. It gives you the list of permitted values, which you can click, and on the right it fills out the ADAM structure automatically. If you wanted to drill down a bit further, you might say, well, yes, but it's limited. Then you can do that. And of course, that means that today, in the first version, you need to do that with free text. So there's a box to add that free text. None of what I'm saying is required. All these fields are optional, as long as you fill in one. Once you've completed your profile, various ways to save it in the different formats, with or without validation. And you can reload previous profiles and version them. So it gives you a computerized, logical structure to put in all those aspects of consent and data use conditions. We published that. It was a big international consortium working on this over a couple of years, and there's videos and all sorts there. What it gives you then is a way now to put this stuff together into a structure, and therefore report it unambiguously. To go back to any consent document you've used or you're aware of, line it up next to the ADAM profile, and I guarantee you'll say, oh, there's nothing about that in here. If someone asked about that type of use, we wouldn't know. Or if there is something in there, 9 times out of 10 you go, well, it's not really clear what we meant by that. That's open to interpretation. So a lot of those problems are overcome by moving it into this kind of structure, and then you can communicate it clearly and consistently. It also allows enhanced discovery, finderability. So there's no point finding a data set that's perfect for what I want to do, but not knowing that I want to do profit-based research and it's not available for that. So you need to, in that discovery step, be able to know what the conditions of use are. And that, again, can be enabled by having those things in a computerized structure. And lastly, it helps you to automate, not fully automate, but to a degree, automate the process of handling data requests. If they're asking for it in a certain country and your profile says it can go into any country, you're good to go. If it says I want to use it in China and yours says no, only Australia, it can't go. A lot of these parts can be automated, and that will sort of triage the easy stuff, leaving just the more nuanced elements for the Data Access Committee to look at. And as we scale data requests and data sharing, Data Access Committees are going to struggle unless we have solutions like this. That's what we were aiming to do with ADAM. I think there's no way I would say ADAM is perfect. It needs to evolve further and be tested. But I think to a first approximation, we've achieved that. I would be happy for people to take ADAM and adapt it and change it, feedback, and we'll all together create an ADAM version 2 at some stage. What we didn't anticipate, now looking back it's obvious, but we didn't anticipate, is that thing in grey. Can we take this structure back to the people who make those ethics committees, write those contracts, and say, well, are you addressing all of these points? Are you really clear what you mean? And in fact, this is exactly what Melbourne Genomics are now going to do after my time there last week. They're trying to put together some standard consent documents, and we actually had a workshop where we tried to map it into here, and they realized, whoa, we need to improve this further. So I think that last thing could actually be one of the big benefits of ADAM, even though it wasn't in the initial concept. I will flag up 2 other things from Global Alliance. I think it's important to do so. I'm in all of these groups because they're all so overlapping. There's a consent codes initiative, which is like the Chinese language, Chinese words. They're prepackaged sets of consent elements, and they're designed for use in research data archives, like EGA, dbGaP. Even there, they only serve about 80–90% of the cases. So I don't think, personally, that approach of prepackaging things is going to work in the wild, in healthcare, in more complicated situations. And there's a data use ontology effort, which is trying to create essentially an ontology, a set of terms and definitions about data use. And they're essentially trying to represent all of the content of consent codes, all of the content of ADAM in a single ontology. I'm part of that group. But that's just an ontology. It doesn't give you the structure. You can't do the logical checks. So I predict that in the future, we'll end up with some type of ADAM approach using a standardized ontology for data use conditions. And I'm starting to nudge in Global Alliance that they start thinking about such a group. Okay, that's data use conditions consent. You can see it's far from a mature field. Different approaches, different ideas, a lot more work needs to be done. I hope I've given you a sense of what the issues are, and then you can decide how you want to start approaching some of your situations. Secondly, second leg of the stool, and I'll put a little bit more time into this. It's what I've been doing for 10, 15 years, that's why. How you find stuff. We have lots and lots of shops out there selling lots and lots of things. If we didn't have eBay or Amazon, how would you know they exist? So if we're going to have lots and lots of data and samples out there, potentially useful for research, how are you going to find them? We need, I'm not suggesting we have an eBay where you pay for everything you get, or maybe that makes sense, but I'm not arguing for that today. But we do need ways to make things discoverable. So let's just think what I mean by that. Normally, when you search a database, you put in a query. That query is designed to be very precise. You want it to find all the things that match and nothing that doesn't match. And then it finds the things you want, and you want to get them, you want to share them. But there's a few steps that happen before you get to that sharing that you don't normally think about. One is, well, the computer's got to go away and do some kind of querying of data somewhere to find the stuff, and then it's got to present to you what it found, and give you ways to click it. Now, there are obvious things, but now let's take away that bit. That is data discovery. It's not intending to share the data. It's intending to be like an eBay. When I go on eBay, I find a product. They don't send it to me just because I found it online. I then have to arrange to access it by paying. Right? Here, the same. This is just to find what exists out there. And that sounds, well, that's easy, isn't it? It's a query interface. Well, I wish. So why is it more complicated than that? And it really is a science in itself. It would be easy if we were selling widgets, but we're selling, if we were selling widgets, we're trying to instead discover and make available sensitive health data. So it's not simple. You have to protect patient privacy. So I've realized over the years there's really a triangle behind this. At the top is discovery, and indeed we want to do pure discovery, as I've just shown in the last slide, which allows users to find and thereby share the existence of the data, not the substance or the meaning in the data. Those other two things, the substance and the meaning, that's data sharing and data analysis. It's very hard to set up any discovery platform that isn't in some respects doing sharing and analysis. If I ask a query of some data and I told there's 50 patients, then I tweak one of the parameters. Oh, but I say age range 1 to 50, and then I go 1 to 51, and I find there's 2 more patients or 1 more patient, then I know there's 1 patient age 51. That's sharing. I've shared information about that patient. And you can imagine with rare disease variants and other things, you can identify subjects this way. Equally, analysis. I could plot the frequency of some attribute of people 10 to 20, 20 to 30, 30 to 40. Then I can plot those counts on a graph. I've done analysis. Right? I can do that for males versus females. I'm really starting to do analysis. So you can see discovery, separating it away from any significant level of sharing or analysis is very difficult. That's why you hit problems. You'd go to the doctors and you say, hey, you've got all these rare disease patients, diagnostics, genomes, can we make them discoverable? Because people with a similar disease patient might like to find it. And you may even have consents from that patient that say, yes, you can share my data for research purposes. The lawyers then step in, and I've had this many times happen, and say, but hang on, you're putting that in a discovery platform for anyone and everyone in this field to query? That's not in the consent. Right? That's wide sharing. If they consider that's a continuum, they say there's a form of sharing involved here, you've not got permission to do that. So you really have to think about these things, and that means you have to set up your technologies in a very clever way. One clever way is to think about, well, what level of data am I sharing or discovering? Of course, there's a fully sensitive data, which you generally do not put in discovery platforms. That's what you do when you're querying databases. Sharing queries are very different from discovery queries. So we would generally, always, I would say, never put the sensitive data at the heart of the query platform. Instead, you would take that data, you'd move it out, do something to it to make it safe. Now, you might just obfuscate it, remove IDs, things like that, group the ages into, 10-year windows, aggregate the data, concentrate on metadata, deal with the data graphically. There's all sorts of things you can do to make the data safe for querying. And an example of that is GWAS data. We run this database here. It's called GWAS Central. It's done so for a few decades now. This is essentially, I guess you all know what GWAS studies are. This is a comprehensive set of all GWAS studies. It's got 3 orders of magnitude more than any other public resource. But it is a discovery platform. It's not designed to give you access to the megabytes and megabytes of data we have. It's designed to let you, via those tabs at the top, set up really powerful queries, and then look at where the signals are in a browser, genome browser. And you can start looking, well, if I look at all immune diseases, or I look at these inflammatory diseases, where have they got common areas of signal? So it's a discovery platform. Then it gives you links to click through to the paper or to the authors. We do, of course, allow some degree of download of about 1,000 markers, but it's not a data access platform. So that's a centralized approach to data discovery, which is easy when we can just suck in all the data from all the publications and set that up. Well, easy, it's doable. But what we want is, for healthcare and more complicated scenarios, we want the federated approach. And that's where it gets difficult. I sometimes call this a lattice rather than a federation or a network, because I'm interested in those connections, the black lines. I don't care what software you have where, as long as they're able to talk to each other or transform the queries between each other. We've developed over many years now a platform for doing this, it's called Café Veriome. We published the last version of it some years ago now. We really need to publish an update. There's been so many developments since. That paper is on my computer. I'm just trying to find time to finish it off. But it's really now a very powerful platform. The idea is this is a technology that you place in your environment beside or on top of your local system. You don't touch your data, you don't touch your system at all. And the idea is it brings discoverability to your content. And no data, therefore, ever needs to leave your safe environment. So that's the top bit there, is stressing that it's then not a database, it's not for accessing or doing precise queries. It's simply a way to enable different resources to become federated for discovery. It's like eBay, the eBay platform. And it leaves the data owner, who puts this around there or next to their data, fully in control of who can query, what they can query, what they can't query, what records, what fields, what they get as a result when they find matches, what thresholds they set for returning, how they obfuscate their data, make their data safe. That's all completely under control. Then the results are yes, no, or counts, or links, or various different ways for the system to respond. You might, if you use this system, decide, well, actually, we'll also let my own lab query the data by this form, and then they can click right through to the data. So it does allow data sharing if you wanted to use that, but that's not the focus of the tool. So then the idea is you take metadata, which is safe, and you anonymize your real data, and you put it in this platform and fill the query indexes and so on. And I've just said this, it's installed locally, so nothing ever leaves home. It's totally safe in that respect. But if you don't want to bother with the hassle of setting that up, we offer a hosting service where we'll set up the system, host it on our servers, but you admin it, it's your tool. That way you just need to worry about the data. And remember, it's not your real data, it's the obfuscated safe data you put in there. And at any stage, if you like it, you can just move that whole thing onto your own servers. Nothing needs to change to the user's perspective. There's a whole process of encrypting IDs in there to make them safe, one-way encryption in this context. And you can take that same software and use it in different architectures. You could use the query function only as a head node, and then use the same software in different places as slaves holding data that's queryable. Or you can have more of a peer-to-peer type arrangement where in a consortium you allow cross-querying between sites. Any pair of sites that don't like each other or don't trust each other, they just don't give that other site permission. And you can equally connect to any other resource or person that can make their system compatible with the API. That's the bit in the middle. It also highlights that that one installation in the two circles there has got the same data, the same software, but they're a party in two different networks with different sharing rules for different aspects of the data. Different discovery rules, sorry. The system comes with lots of query builder functionality, access control, ways to set up groups, different output options, as I've alluded to. Here's just an idea of those query interfaces. They're designed to be very straightforward to use. This is a phenotype section from one of our implementations. The plus minus allows you to add more rows or remove rows. The pull-down list allows you to query for any of the attributes in that network. It polls the network and determines what attributes exist, so that's a dynamic system. All the possible operators in the middle, and if you want to set a threshold value, you can. Basic query, just and Boolean logic. Advanced query, any combination of Boolean for any of the parameters in the query. That canned query should be up one row, that word, because the canned queries allow you to save queries for later use and rerun them. And all the queries are logged, so you can see who's doing what. Here's an example, very quickly, the simple query: how many subjects age 45 and over 45, and 4 different users in different places, or 4 or 5 different users, Sarah, Fred, Andrew, and so on. We have this system in the top right. The system is aware of the settings for each of those users. Each site determines what each of those users can do. Bottom line is, if they all do the same query in the same network, they'll get different answers. As in, some will get responses from some sites, some won't be getting any responses because they weren't allowed to query those sites. The responses can come back either in the open access or a restricted access column, and if it's in the open access, it means you can click through and get to the data. If your permissions only allow you to see restricted access, you just get counts. That's just to give you a flavour of how the data controller is fully in control. Here's how that result might come back. You can see only one of those sites is allowing this person to query, and that result has been put into the open access, so they can click on that green icon and get to the data. It is semantically aware, so you can impose or not, but you can impose public ontologies on the content of these systems and these queries, which is very powerful for querying, or you could use local vocabularies, restricted lists to do this, but it's not required. Different sites can make different choices, and the system is aware of that. Obviously, we're trying to make this based as much as we can on standards, whether that's the query API shown here or the data models behind it, so that we can do that. Remember the Lego bricks, the federation part, if people want to federate with us and not use our software. And a lot of that is through Global Alliance, obviously. This is the overall logic then. So at the top, you've got your data, which you keep locally. We don't touch that. You take that, create a version of it that's enhanced or obfuscated, whatever, into a format that you want to make queryable. Put that into various indexes and stores. On the left there, you've got the query being created. Now, that might need to be processed. You might store the data by date of birth. They might be asking for age queries, so you sometimes have to do a bit of manipulation. That's an obvious example. Then that query gets split into querying the genomics data store, or the omics data store, and the textual data stores. And then once those two queries have done, they're unified, depending on what the Boolean logic was. And you might need to have a feedback loop going on behind the scenes. If they ask for people who took that drug and got a side effect within 3 months, you might want to say, well, I need to know who took the drug. Well, then your system will have to be aware of when they took the drug. Then you can work out what 3 months is. Then you can answer the second bit of the query. So sometimes a bit of feedback loops in there. And then the different types of display. So that's the logic behind the system. But we've also put a lot of effort into thinking about the security of this. So I've already stressed about how the data are processed to go into the query environment, and that's not your original data. That should be safe data by that stage. There's the query itself. In that whole process there, you can do things to make the queries, to limit some queries for some people. That's based on differential privacy type approaches where you make sure that they're not finding different data sets if an individual is or isn't present. That sounds a bit counterintuitive, but for example, if the real result is 15, you might add a random number to that. So you move things around a bit, and they never know quite how many people there. But it's not a database query where you're trying to find exactly the data. You're trying to get a sense of what's in the database. So that's fine. And then you've got the user profiling, how you do the ID proofing, and then the authorization, authentication levels as well. And we log all the queries. One group now wants to sort of use an AI approach to sort of saying, is anyone gaming the system? Is someone doing lots of queries trying to find someone? You could also, we haven't done this, but it's a concept we're thinking about, give a kind of privacy budget to each individual in the database, in the system. And if each time a query hits them amongst the results set, their budget goes down a bit. And at some point you say, well, stop returning that person. So we're thinking about whether that makes sense. Especially, it creates challenges in the rare disease world where there might only be 2 subjects. So you can see why you start to get a sense, I hope, of why this is not easy. You don't just build a query interface, job done. And there's all the different functions in the software. You know, there's a messaging part. There's you can change the appearance so it looks like your own system, build it into your own website, and that's essentially the whole system, which what I've tried to give you a flavour of. So without talking any more about my own software, even though we are proud of it, just to give you a sense of how widely it's being used, and stress this use case here. So a year ago, we started an EU project called Solvard-D, a €15 million project. And this January, we started an infrastructure project called European Joint Programme in Rare Disease. That's a €55 million programme, essentially trying to put support in data management support and other support around rare disease in research and diagnostics in Europe. And you can sort of think of this as an infrastructure project. That's the Solvard-D groups. I want to make sure they're all shown. I'm co-coordinator on that one. And then what we're doing there is in Solvard-D is saying, well, if you do an exome, you can work out, you can diagnose about 40-odd% of rare disease patients. What about the other 60%? Why don't they fall out? So we're trying to throw everything we can at these cases, trying to work out how we increase the diagnostic yield. That means we're going to have lots of experiments going on lots of samples and lots of patients with lots of networks, and we need to track all of that and make what's going on discoverable to people inside the project and outside to a degree. So that's one major discovery use case. And then there's this larger infrastructure. So in Europe, all rare disease, about 1,000 rare disease units, specialist units, have been grouped into 24 consortia. They're called European Reference Networks. These then now have a particular disease focus, like might be pediatric cancer, for example. And with those 24 ERNs, we're working to say, well, what do you need in terms of IT and management support and analysis support and so on? And one thing they clearly will need is a way to, within their networks, find what rare disease patients they've got and what data they've got. So there's another major discovery application. In that one, there's 4 main work packages for that. Work package 10 is coordinating all the other, these are the IT work packages. 10 is coordinating all the IT work packages. I'm co-lead on that. I'm also co-lead on 12, which is about FAIR, making data findable, accessible, interoperable, reusable. I'm focusing on the FAIR bit here today. And that's, on the F, the findable bit, discovery, hence why it's relevant to the talk today. We built some tooling already, which we're now starting to deploy. It's just an implementation of Café Verium that we're calling RD Nexus. Rare disease, network exploration of the unseen. We're stressing the unseen. The users don't get to see the data, but they can explore what exists in a networked structure. So RD Nexus now exists. We're putting real data in and showing it to the different ERNs. So they want to adapt it. But one group in particular is very keen on it for mitochondrial disease. So we've made adaptations so that they can also query the mitochondrial genome and look at mitochondrial haplotypes, so things you wouldn't need to do in a nuclear genome situation. And all of these different modules for querying can be used or not used in the system and reused. And they also want a different type of output, which is shown at the bottom. Another very neat idea, I think, this wasn't our idea, this came out of Canada initially, rare disease model matching. So in Canada, they raised funds, and we've made sure we've put funds in place so that when someone discovers a new rare disease gene, they'd like to hook up with model organism researchers to do functional studies on those genes to see if it really is the gene. So how do they find those model organism researchers? How do they find its discovery again? So there's a discovery interface for model organism researchers so that rare disease researchers with a new gene can hook up and will fund pilot studies in each of those cases, well, until the money's used up. That's RDMM. Canada's now doing the same with their pot of money. Japan's doing the same. Australia's got a project like this as well. But on a different level, how can you find model organism researchers anywhere in the world? Not giving you funding, but just give you a way to find model organism researchers and query for those. So that's model matching. So they're different, but they're related, and we've set up those capabilities with Cafebarium as well. Right. Hope that's given you a sense that this data discovery, think of it as eBay for biomedicine, is really needed. I do think, actually, off the record, there might be a case for paying for some of these assets sometimes, so that, again, another incentive for sharing. And I think if we can create a marketplace for that, then assets can take on their own value, which might be zero in many cases, but some really precious assets might be higher. Biobanks are already charging for access to the data. It's called a processing fee, but it's a charge. And that can be many thousands of dollars for a single data supply. So I think we're moving into a new era there, and we have to, because the funding agencies can't fund all these systems forever. Even though they would fund them indirectly by funding the research, which would then pay, but you get my point. There needs to be a market. The best systems need to survive and the others not. Thirdly, lastly, data linkage. And this is something that we really started to struggle with when we started trying to make healthcare-related data discoverable. Healthcare data, pretty much everywhere in the world, certainly in Australia, sits in many different places. And when I find a biosample of interest, I want to know, is there clinical data? When I find some secondary care data, I want to know what was in their primary care record. You need to link these data together to make them useful, obviously for healthcare, but also for research, for discovery and sharing and analysis. So how do you do that? Because as soon as you start moving data around that you want to link on an individual level, you need individual identifiers, whether that's name and address, that kind of stuff in Australia, whether that's a national health number, or whatever. You need identifiable information. So how can you do that, but not have such an information governance burden, because you're handling identifiable data, that you don't get anywhere? So we are looking at how you can essentially, listen carefully, link data that is anonymous. If I'm seeing blank faces, then you're getting it. Because if it's anonymous, how can you link it, right? That's what, but if you could, right, many of those information governance and security issues go away because it's anonymous data, but you can still do the linkage. And this just stresses why all the different types of data you might want to link for all the different users. That just says what I said. Processing these data, linking it is risky. Can we link data that are effectively anonymized? The context of this is in the UK, virtual institute, national institute called Health Data Research UK, which is trying to enable team science at scale for accessing, providing healthcare data for research. And it's at the bottom there, it says it very clearly. In the UK, we've really got great healthcare data, but it's fragmented, the field is crowded and competitive, so it makes it hard to do any of this. So by creating a national virtual institute, we're trying to get many, many different groups working on solving this on a national scale. One of the big, there's 3-4 big pillars in this whole program, but the one that's going to be advertised this May is called Digital Innovation Hubs. This is where the data provision, the informatic pipelines meet the researchers and bring it together so that they can get the data and find the data and do the research. That's the biological research, the biomedical researchers. And it's been 2 years in the design of what a digital innovation hub is or isn't. It's still, I think, being refined, and the call is coming out in May. And part of working out what a hub needs to do, or how it needs to do it, was to fund 10-month sprints, Digital Innovation Hub sprints, sprint exemplars, to sort of put some of the cornerstones in place for hubs. Very competitive call, but we were lucky enough to get one of the 10 awarded sprints. I'm leading this one, and it's about linking anonymized data, making data anonymized in a way that you can then still link it. Here it shows the idea. It's not such a great graphic. I list the partners in the project on the right. On the top there, N, LLR, WN, they're just different regions around the Midlands with different Nottingham, Leicester, Lothian, Rutland, West Midlands, and so on. And that's primary care data. And then on the slightly to the right, you've got the secondary care data. And then you've got biobank data. And we're looking at how we can enable these to be linked up. Now, we're not going to link it up and then share it because you can't run before you can walk. We're going to make it discoverable. So link it up and make discoverability on, so you can say, here's a biosample, but there is primary care data, and this is the, the basic diagnosis and whatever else. And doing that with companies, and doing this in the context of multimorbidity as a pilot test case. So that's the idea, but the core thing is this technology from a company called Privitar. NHS Digital looked at all privacy companies and settled on this one, who are apparently way ahead of everyone else. So we brought them into the consortium. NHS Digital is an effort in the UK to suck all the data into one big central database. Talked about this at the beginning, central versus federated. Centralise everything. Stick the security and the linking all in that environment, all easy. It's what Genomics England are doing. Maybe that's the future. Maybe that's the way the UK will evolve. I don't know. But we are looking at the alternative, and I don't think they're exclusive, I think you actually need both, of doing this linking in a federated arrangement. And there's lots of reasons to do that. The data's more real-time. People will know about the biases in the data if you're using local data. There's lots of reasons why you want a federated approach as well. And this is just, buckle in here. It took me a day to get my head around this, and you've got 5 minutes at most, right? The idea is, on the left here, here's the different sources of data. Right, and I'm showing the IDs. Contributor one's got some records. Oh, he's got 2 records about ID 123. He's got another ID 234. The second contributor's got an ID providing data for someone 234. Okay, they throw that to somebody called a data pooler. Now, before they throw it to them, they doubly encrypt the data. They do that using public keys from those 2 middle boxes. That's the pooler and one called a trusted intermediary. I'll come to that group in a minute. So they have public keys. The contributors, therefore, doubly encrypt the data. So think of it like there's your ID, you put it in a box, and then you put that in another box. It's very safe in there. No one with only one key or access to, they can unlock only one box, can get to the ID. So it goes to the pooler, very safe. The pooler then passes it over immediately to this trusted intermediary. And if you look at what's happened to the IDs, in that encryption, 123 became A, became E. But the same process done on that same ID, in that same data set, turned it into a C, then a G. That encryption method there is probabilistic. Each time you run it, you get a different answer. But you can always go back to the same original value. So now, in that EFGH layer, the linkage relationships are lost. That's deliberate. So it then goes to the pooler, who pulls it together into one set. Now you've got 4 records in the same pool. He passes that on to the intermediary. They use their private key to take off one of those boxes, and you end up with ABCD again. But they can't get to the original IDs, because they can't unlock that second box. Then the magic happens, and this really is magic. They do not unlock that box. They cannot unlock that box, but they can reach inside, change those IDs to something else in a consistent way. And take the hand out again. So they change, and then, of course, the box now is a different color. So it's now WXYZ, which they pass back to the pooler, and then the pooler can take his lock off, and he sees the IDs, but he doesn't see the original IDs. He sees the ones that have been changed into. And they can now see the linkage relationships. Throughout the whole process, these data are completely anonymous to all the parties. So it's anonymous data, but it allows linkage. They eventually link it up, hand it on to the users, and they tokenize it, so they hand it out with different IDs or no IDs, depending on what the downstream use case is. So that model is what we've essentially taken the Privitar's concepts, putting it into practice in this model, looking at how we use that for discovery or sharing, and that's a work in progress now. We'll finish that by the end of the year. And you could take that same technology and imagine using different bits of it in different arrangements. It could be that the pooler and the intermediary are the same group, but with a firewall between the two. I mean, there's, it just gives you the concept here. And that just shows you, in case you didn't follow my explanation, what happens to the IDs. You can see they're all there. The IDs, as hidden IDs to everyone, they're hidden until it gets to that bottom right part where they get changed to something else in the box, but they don't see that, they only see the outer side of the box. And you can see how it all flows from there. That took me now, the reason that took me a day to get my head around that, partly because I'm probably quite stupid, but it wasn't presented to me as clean as this. This is me sitting down and working out what slide would be needed to explain something in 5 minutes that took me a day. I hope the concept has come through at least. And so I've told you about that. I'm not going to put a summary slide in summarising all the bits that I've gone through, because I think it's really simply summarised there. If you don't get those 3 bits under control, you're never going to get very far in sharing any data. There's other legs to this stool, of course, but those are the 3 I've talked about today. And I want to acknowledge my own group, the 3 major consortium relevant to this work, and all the funding sources. Thank you.